Hello, environmental science students, and welcome to the last video notes. We're going to be looking at renewable energy. We just finished studying non-renewables, so we saw fossil fuels, oil, coal, and natural gas, and as well as nuclear energy. Those are non-renewables. Now we're looking at renewable. 18.1 specifically goes over geothermal and biomass. So, why do we need alternative energy sources? We looked at how efficient nuclear even is, 1/4 compared to a ton of coal. Well, one of the biggest things is that renewable will actually decrease our air pollution and the greenhouse gas emissions, as well as providing new jobs. Two very important things. The first one we're looking at is biomass energy, so that's your first bullet point. It is a material such as wood, manure, grain, basically biomass being any type of plant material, making up from living organisms. And we will burn it to boil water, to produce steam, to turn a turbine, to power a generator that's magnets around a coiled copper wire. Biomass can be used for heating, cooking, lighting, fuel, or electricity. But it has to be, we're burning something. So we're burning wood, very specifically. All right, I'm going to change slides. Pause it if you need to. For the energy sources, it does come in solids, liquids, and gases. Solids, like I said before, being wood. When you're looking at liquids, that's the E85, the ethanol from corn. And then gases would be methane, the landfill gas that we looked at. It's part considered natural gas, but if it's produced by a landfill, then we're considering it biomass. So that's where things get a little sticky. Yes, methane is natural gas, but if it's produced by a biomass, like landfill, then we're going to consider it a natural biomass energy. The benefits, pros and cons. Pros being that it's not a huge carbon dioxide increase. Yes, methane, burning methane does produce carbon dioxide, but methane in the atmosphere is worse. Remember, 20 times worse. For the costs, you have habitat destruction, deforestation, and then soil erosion, because we're removing those trees and exposing the soil. It can also affect water. It can actually reduce the water that is in the area, because a lot of times the tree's roots will hold in different aquifers. The next one is geothermal. This is a way to heat your homes, as you see from the picture to the right. Basically, underground, it's always 55 degrees, 55. So if you have geothermal cycling, it'll be 55 in your house all the time. Well, that's great in the summertime. It'd be crazy cold. So you need a heater to at least heat it up, 15 degrees to 70. In the winter, 55 is great. If it's negative 20 out, it's still going to be 55 in your house. You still need a heater to heat it up to 70. So it eliminates the air conditioner, eliminates the Freon, which is really bad for the environment. So you only have the furnace, and then you'll have the geothermal cycling. It uses the natural heating of the earth, so there's no extra energy being used to keep the 55 there. Pros and cons of geothermal. A lot less air pollution because you don't have to heat up as far, and you don't have to cool down as much. So same thing with no AC. I know it's not written on there, but we'll add that to the benefit, is that you'll end up having no AC. So no Freon, no air conditioner. With the costs, it's not sustainable if everyone lives very close and everybody has it. You'll use up the heat from that ground too fast, and can actually damage the ecosystem, because again, if you look, it can actually trigger some earthquakes. So it's only good if you're in like a rural area. So it's very selective. All right, 18.2 is hydropower and ocean power. You are not doing homework on 18.2. You're doing 18.1 next week after 18.2, and then we're done because we start our research projects. Yes, we are that close to being done, people. 3 weeks of this unit, and then we're done. We have 3 weeks, test, and then research projects. With 18.2, hydropower and ocean power, the reason you don't have homework on it is because we've talked about it a little bit already, and the next one you need to learn more on. With hydropower, these are dams. So you have water that's pushing the turbine that's powering the generator. So you actually have water that's pushing the turbine that's moving the magnets around the coiled wire. So you're not actually boiling water on this one. It's if you look here, the water, they're pushing it, they're holding it back, and the pressure from holding it back will cause it to go through the narrow opening, which is going to turn the turbine, and then it bubbles out the side. So there's actually turbines in there. We have one in downtown Elkhart. When this happens, there's a lot of pros and cons. Switching slides. With the pros, there's no air pollution. It's completely renewable. It's very cheap. The costs, there's a lot. Fish can no longer migrate up the stream. They've made fish ladders for them. So on the side, it'll allow the fish to go up without damaging the water flow. But that's something extra that needs to be built. It traps the soil, so the soil can't actually travel downstream and will build up behind the stream. Also, that reservoir that builds up behind it not only can displace people, meaning that it splits communities in half, did that with Japan in a huge way, but it also, that reservoir also heats up, so it actually changes the temperature of the water, which can affect the wildlife. 18.2 also goes over tidal energy, being that we'll generate electricity from tidewaters. As the tides come in and out, they'll actually push turbines to power a generator. These are only in areas where there are dramatic tide changes very quickly. Like in Nova Scotia, Alaska, they have very dramatic tide changes. Within 20 minutes, you'll be under, 8 feet of water. It's that quick. We don't see it around here, so it's only in select areas as well. Thermal energy, using the heat. Again, heat to boil water to produce steam. We'll use solar energy to use the heat that is there. So they call it OTEC, Ocean Thermal Energy Conversion. So it's going to use that warm ocean water to boil water to produce steam to turn a turbine. It's right there. All right, 18.3, we are going to go over this one. We're actually going to have a professor from Notre Dame come in. He's a professor/researcher that makes solar cells, Dr. Mark Wisty. Hopefully he'll come in and talk to all classes. I'm not quite sure as of the 15th of April, but we'll see. With the solar cells, there's two different types of solar heating. There's passive and active. Passive being, it's how you built your structure to harness the energy. So did you put in windows that will, help heat up the building? Did you point the building in a certain direction as you were building it? Did you put on pine trees on the north wall to block the wind to keep your house warmer? Those are passive areas. Active is actually when you're using technology. That's the big difference right there with the tech. So you're using solar panels to capture and store it. When you're doing active with the solar panels, there's a couple of different kinds, and they may not be listed up here, but there's the photovoltaic, where it's actually going to use the solar cells and electrons on usually a silicon liner. They're trying to do research on different types. There's also dye-sensitized, where they'll actually use a powder and dye it a dark color to let that absorb. A lot of times what we'll do is we'll use a specific kind of glass or medium to concentrate the solar energy, because the solar panel is going to take the electrons and use those and transfer them in a material. So it forces them to bounce a certain way so that we can put them along a circuit. Again, pros and cons. With solar power, it's the sun. It's always there. Whether or not the clouds are in the way, though, that's one of the issues. We are very cloudy around here, so solar power may not be as efficient because we kind of need the sun for that. It's completely and utterly clean. There's no air pollution in the process of doing solar power, but the problem is that making the solar panel actually does produce carbon dioxide because of the materials that are on there and the circuits to harness it. So yes, it might seem completely clean, but that's only half true. The process of solar power is, but the process of making the solar panel isn't. I don't agree with the low maintenance that's on the board. They are very sensitive. They need to be positioned correctly. If there's, windstorms and things like that, you need to make sure that they're anchored properly. Costs. Yes, they said some pollution during manufacture. Depending on which solar panels it is, it can be more than others. And depending on what it's for, it can be expensive. All right, wind power, wind turbines. Turbine is a hat. Turbines. It's going to convert the wind's energy to kinetic by pushing the blade, which powers the generator, which produces electricity. And you can see in the picture that the generator is actually inside of this. In some wind turbines, I've actually seen a bump right here. That's an office. So on some of these, there will be like a bump up here. That's actually an office that you could actually like climb up and get into the office in each one to help control and maintain it. The problem with wind turbines, pros and cons. The problem with wind turbines is that the wind's unpredictable. It could be producing electricity at 3 a.m., but no one's there to use it. We have no way to store the energy, so it could be completely lost. It could overpower, so they may have to shut down the wind turbines. That's what happens in Michigan, is that they overpower the grid, and they have to actually cut them off because they can't do anything with the extra energy that's there. Again, multi-million-dollar idea, just remember me. Benefits, there's no pollution or greenhouse gases produced during making, like turning the turbines, but there is pollution in making the turbines. Next. Anytime, next. There we go. All right, 18.4, hydrogen energy, we talked about that a little bit. When we're looking at it, it's the algae, so we're breaking it down and using the methane. Moving on. Pros and cons. We can produce it very easily. It's very renewable. Costs, actually splitting the water. It's expensive. It's pricey. Not necessarily difficult to do, but difficult to be able to get our hands on. That's why it's expensive. For fuel cells, this is when you have the hydrogen and the oxygen. They talked about this in the switch videos, to where the only thing that you have left are water and heat, and we use the heat to boil water to produce steam to turn a turbine. So we're actually splitting it. But this is the hydrogen fuel cell that they talked about for cars when we were looking at batteries. It is one that they call future, but one that they know it will not be sustainable because of the price and the availability. All right, make sure that you turn these in. Have a good day.